This video looks at section 3 of the functions notes, and in particular this section is focusing on finding unknown coefficients of a function. So just to kind of recap pieces of information that you might remember from junior cycle, or just to make sure that you're kind of okay with them. We've two main type of functions that we're going to be looking at when we're finding unknown coefficients, and the first one is linear. And when I say linear, a linear function is just a line. So a straight line that goes from point A to point B. And we should be fine with them. We've seen them in coordinate geometry of the line, and we should be fine with graphing them even from coordinate geometry of the line. However, the second type of function that we're kind of dealing with is a quadratic function. Now, we all know how to solve a quadratic function. It's in the form ax squared plus bx plus c, and I'm hoping that we remember what a quadratic function looks like as well. It's the u and n shaped graphs, so the happy and sad face graphs. So I'm hoping we all know what they look like. Sometimes when we're in maths, we're asked to find the coefficients of a function. Now, what that actually means. So if they, for example, tell you that you have the function x squared plus bx plus c, and they give you 2 points. So they give you -1, 0, and they give you 4, 5. A question might ask you with this information, so with these points and with these functions, to figure out what is b and c. Now, that's what this whole topic is covering, and obviously there's two types. So the first one being linear. Now, a linear graph is going to look something like this. So it's going to be ax plus b. So there's only one x term, and the x term is to the power of 1. And then the second type, which we've already brushed over, is the quadratic. So that's a term that's ax squared plus bx plus c. Now, again, we should be fine with the quadratic from algebra, and we should be fine with the linear function from coordinate geometry. However, to do these types of questions, there's two steps that we have to follow. The first step is you sub in the given point into the function. And then the second step, there's kind of two possibilities for the second step. So if you're given a function that has one coefficient, you should just solve the equation. However, if you're given a function that has two coefficients, you need to solve it using simultaneous equations. And if you solve those simultaneous equations, you'll get the two unknowns. Now, we should be fine with simultaneous equations as well. We saw it in the algebra chapter. We also saw it in the coordinate geometry of the line chapter. So there are two places we've seen simultaneous equations before. However, I am going to go through exactly how to solve them in this video. So the first example I'm going to go through is question 4.1. And it says here that f of x is equal to ax plus 3 defines a function. So again, we just have our function, and the function is f of x is equal to ax plus 3. First thing you should do is decide whether this function is linear or quadratic. So linear or quadratic. Now, again, how do we know which one it is? So a linear is going to have just an x. A quadratic will have an x squared. Of course, there could be other things after both of those. There could be numbers here or like here. But the main thing that we're focusing on when we're looking at linear is that there is only an x, and in the quadratic there's an x squared. So when we look at this function here, we know that this function is linear. The next thing we do, so step 1, if you go back to the previous slide, is you sub in the given point. So what we have here is it says f of 2 is equal to 9. So I'm going to sub in 2. So this will become a by 2 plus 3 is equal to 9. So then this will become 2a plus 3 is equal to 9. And now we're on to step 2. So if you're looking for one coefficient, you just solve the equation. If you're looking for two coefficients, you solve the simultaneous equation. So here we're only looking for one coefficient. We have the a. So we just solve the equation. So here, this is going to become -3 from both sides. So you're going to get 2a is equal to 6. And then you're going to divide both sides by 2. So in the end, you'll be left with a is equal to 3. Now the next example is question 4.2. And it says the diagram on the right shows the graph of the function g of x, where g of x is 3x squared plus bx plus c, where x is an element of or and b, c are an element of z. Now, remembering that or stands for real numbers, and real numbers are all numbers. And z here, I'm hoping you're aware that z is what we call an integer. And an integer is positive or negative whole numbers. So if you get b or c to be like minus 27.3, you know you're wrong straight away because it's not an integer. So if we go back here and we look at what we have, so we have g of x. Now I'm going to rewrite it as g bracket x is equal to, because I think that's much easier to kind of work with. But you can leave it exactly like the way it is if you prefer. Now, the first step when we're finding unknown coefficients is to sub in the point. So we have 2, 0, and we have 3, 5. So the first one, the 2 is our x, and the 0 is our y. And we know from right the way back with the notation video that g of x is the same as saying g dot x with the arrow. And that's the same as saying y. So we can rewrite this as y is equal to 3x squared plus bx plus c. And then we just sub in the point. So what 0 here is y is equal to 3 times, replace the x with 2, and replace the x here with 2 as well. And then we have plus c on the end. So to figure that out, what we have here is this is going to become 0 is equal to 3 times 2 squared, which is going to give us 12, plus 2b plus c. So I'm going to change this so that we have the number on one side and the two unknowns on the other. So we'll minus 12 from both sides, and we'll end up with minus 12 is equal to 2b plus c. And I'm going to rewrite that with the minus 12 on the right hand side. Perfect. Now I'm going to put a little box around that so we can come back to it. Now that's the first point subbed in. I'm going to sub in the second point here now. So the second point we have 3 and 5. So the x is 3 and the 5 is y. So again, I'm going to rewrite down. So y is equal to 3x squared plus bx plus c. So we have y is 5, so I'm going to replace y with 5, and then 3 times 3 squared plus b times 3 plus c. So this here will stay as 5. This becomes 27 plus 3b plus c. Again, I'd like the 27 here maybe to be on the other side with the 5. So when I minus 27 from both sides, I'm going to get minus 22 is equal to 3b plus c. And I'm going to rewrite that over here. So we have 3b plus c is equal to minus 27. And that's the second equation that we have. Now, so I'm just continuing on the next page, and I've written down the two equations that we had. So 2b plus c is equal to minus 12, and then 3b plus c is equal to minus 22. So the next thing I'm going to do is I'm going to use simultaneous equations here because we have two unknowns. I'm going to put a line underneath this here. And the first thing I'm going to do is I can see that the number is the same in both equations in front of c. So there's a 1 in front of both the c's here. However, the sign is the same. So we need the sign to change. So I'm going to multiply the top line by minus 1. So we'll end up with minus 2b minus c is equal to 12 all over 3b plus c is equal to minus 22. So then we say to ourselves, is the number in front of c the same? It is. Are the signs different? And they are. So then we can add the two sides. So we have minus 2b plus 3b. That's going to be just 1b. Minus c plus c. Well, that's going to give us 0. And then we have 12 take 22. And 12 take 22 is going to be minus 10. So what we're left with is b is equal to minus 10. So then we take the first equation, so 2b plus c is equal to minus 12. We now know that b is minus 10, So we sub that in. 2 by minus 10 is going to give us minus 20 plus c is equal to minus 12 plus 20 to both sides. And we'll get that c is equal to 8. So the answer that we get then at the end is b is equal to minus 10, c is equal to 8. They told us that g of x is 3x squared plus bx plus c. So then it actually is 3x squared minus 10x plus 8. Now, at the beginning, it told us that b and c are elements of z. And we said that z was an integer. And I'm hoping that you can remember that an integer is a positive or negative whole number. And if you look here, we have b is minus 10 and c is 8. And they are both positive or negative whole numbers. Question 4.3 then I'll do next. So the diagram shows part of the graph of the function f of x where x squared plus bx plus c, where x is an element of R and b and c are elements of z. So very similar to the last question. The graph intersects the x-axis, and making sure you're aware that the x-axis is the axis that's along the road and the y-axis is the axis that is up the wall. But the graph intersects the x-axis at minus 1, 0 and 2, 0. So you can plot that in there if you want as well. So minus 1, 0, 2, 0. Calculate the value of b and the value of c. So the first thing we're going to do with this is we're going to sub it in, because that's what we were told to do. So I'm going to rewrite it as f of x is equal to x squared plus bx plus c. We also know that f of x is y, so y is equal to x squared plus bx plus c. Now the first point we have is minus 1, 0. And we know minus 1 is x and 0 is y. So we'll get 0 is equal to minus 1 squared plus b times minus 1 plus c. So this becomes 0 is equal to 1 squared, which is just 1. Then this will become minus b plus c. So I'm going to bring that 1 over to this side. So I'm going to minus 1 from both sides. And we'll get minus 1 is equal to minus b plus c. And then I'm going to rewrite that as minus b plus c is equal to minus 1. The next point we have then is 2, 0. So here we'll have 0 is equal to 2 squared plus b times 2 plus c. So then this will become 0 is equal to 2 squared, which is 4, plus 2b plus c. I'm going to minus 4 from both sides. So we'll get minus 4 is equal to 2b plus c. And I'm going to rewrite that again, just so that the number is by itself on the right. And that's the equation we have here. Okay, so again, I've just gone onto a new page and I've just copied over the simultaneous equation. So I have minus b plus c is equal to minus 1 and 2b plus c is equal to minus 4. So I'm going to look at the c's first and I'm going to say, right, is the number in front of c the same? And yes, it is. There's a 1 in front of c on both lines, but the signs are the same. So we're going to have to make the signs different. So I'm going to multiply both sides by minus 1. So we'll get b minus c is equal to 1. And then the second line stays the same. So it's 2b plus c is equal to minus 4. Now, so then we say to ourselves, is the number in front of c the same? It is. Are the signs different? They are. So then we can add the two lines together. So we have b plus 2b. That's going to give us 3b. We have minus c plus c, which will give us 0c. So I'm not going to write that in. And then we have 1 minus 4, which is going to give us minus 3. Now, we know 3b then is minus 3. So if I divide both sides by 3, that would give me that b is equal to minus 1. Then I know that b is minus 1, so I'm going to write out the formula from the start. So minus b plus c is equal to minus 1. I know that b is minus 1. So this is going to be 1 plus c. And we get that c is equal to minus 2. So what we get then, if we go back to the start, it said that f of x is x squared plus bx plus c. We know that b and c now, so this becomes x squared minus 1x minus 2. Now, if you can remember back to the start of this question, part 2 said that k and minus k plus 14 is a point on the graph. So where k is an element of z. So remember that z is an integer, and an integer is a positive and negative whole number. And it just tells us to find two values of k. So the first thing we do, and we don't start freaking out, is we go back and we have a look to see what the equation is. And we have f of x was x squared plus bx plus c. Now in the first part we figured out what b and c was, and we figured out that we got x squared minus x minus 2. So again, I'm going to rewrite this as y is equal to x squared minus x minus 2. Now here what we have is we have k and minus k plus 14. So the k is our x and the minus k plus 14 is our y. So here we get that y, so we get minus k plus 14 is equal to k squared minus k minus 2. So this stays here as minus k plus 14. K squared is just k squared minus k minus 2. And I'm going to bring everything over to the one side, so I might just add k, take 14. Over here, add k, take 14. So this will be 0 on the left, and we'll be left with k squared, and then the k, minus k plus k will give us 0k, so I'm just going to not write that there. And then we have minus 2 minus 14, which is minus 16. Then what I'm going to do is I'm going to add 16 to both sides. So we'll be left with 16 is equal to k squared. And I'm going to rewrite that just up here so I can get a bit more space. And I'm going to put the k squared on the left hand side. So we have now that k squared is equal to 16, but we want what k is equal to. So I'm hoping that you can remember that when we have k squared, to get it to become k, we square root both sides. So this will become the square root of 16. So we'll get an answer that k is equal to 4. And for this, it's plus and minus, because if you think of it, if we go minus 4 squared, that will give us 16. And if you go 4 squared, that will also give us 16. So there is two values of k, and the two values of k are plus 4 and minus 4. So that is the answer to this question. Now the last example I'm going to go through is this one here. So we have the graph here on the right hand side, and the first thing is it tells us that f of x is equal to x squared plus bx plus c, and it wants us to find b and c. So we have 2 points here. We have minus 1, 0, and we have 4, 5. So we have that f of x is equal to x squared plus bx plus c. This can be rewritten as y is equal to x squared plus bx plus c. The first point we have x and y, and the second point we have x and y. So when you sub that in, it's going to become 0 is equal to minus 1 squared plus b times minus 1 plus c. So we'll get 0 is equal to 1 minus b plus c. So this will end up being minus 1 is equal to minus b plus c. So we'll get minus b plus c is equal to minus 1. The second point we have then is 4. So this will become 5 is equal to 4 squared plus b times 4 plus c. We get 5 is equal to 16 plus 4b plus c. I'm going to take 16 from both sides here. 5 minus 16, which is minus 11, is equal to 4b plus c. So this would be 4b plus c is equal to minus 11. So I'm going to write them down here. I might do this bit in blue. So we get 4b plus c is equal to minus 11. Minus b plus c is equal to minus 1. I'm going to multiply the top line by minus 1. And we'll get down here that this is minus 4b minus c is equal to 11. And then here this will stay as minus b plus c is equal to minus 1. Then we add them together. So minus 4b minus b, we get minus 5b is equal to 10. So if minus 5b is equal to 10, b is going to be equal to minus 2. So we have 4b plus c is equal to minus 11. So we have 4 times minus 2 plus c is equal to minus 11. So this is going to be minus 8 plus c is equal to minus 11. So then I'll just write this out. So minus 8 plus c is equal to minus 11. Plus 8 to both sides. We'll get that c is equal to minus 3. So then we knew that f of x was equal to x squared plus bx plus c. We know that b is minus 2 and c is minus 3. So this becomes f of x is equal to x squared minus 2x minus 3. Now, so in the first part we saw that f of x was equal to x squared minus 2x minus 3. The next thing we need to do is find the coordinates of P and Q. P is where the graph intersects the x-axis, and Q is where the graph intersects the y-axis. Now, if you can remember from coordinate geometry, when a graph or when a line intersects the x-axis, y is equal to 0. And when a graph crosses the y-axis, x is equal to 0. So we have here, remembering that we could rewrite the function as y is equal to x squared minus 2x minus 3. So first of all, I'm going to find where point Q. So we know that x is equal to 0. So then y is going to be equal to 0 squared minus 2 times 0 minus 3. So we get that y is equal to minus 3. So then P has to be, if x is 0, and y is minus 3, then the coordinates of P are 0, minus 3. Now, where the graph P cuts the x-axis, y is equal to 0. So in this case, it's going to become 0 is equal to x squared minus 2x minus 3. I like to write it so that the 0 is equal to 0 is on the right-hand side. So it's going to be 2x squared minus 2x minus 3 is equal to 0. Now, to solve this, we use our box method, and when you use your box method, you're going to end up with x plus 1 and x minus 3. So then x is going to be equal to minus 1, and x is going to be equal to 3. So what we'll be left with then is minus 1, 0, and 3, 0. So P could be either one of these points, but if you look here, minus 1, 0 is already written down here. So then P is 3, 0. And that's that question done.